All right, so we are doing rate of change and domain, and this is target 10C. Learning goals. I can find the rate of change given a table, calculate or determine information when given a table, determine the average rate of change of an exponential function and express the rate of change in words as it relates to the domain, identify an error in a given scenario and correct it, and finally use information in a graph to answer questions regarding rate of change over different domains. So let's look at the first example. We need to use the table to answer the following questions, and our questions are basically who read the fastest and who read the slowest and what are their rates. So the only way to effectively do this is to find all of their rates, and to do that all you need to do is take their x divided by their y. So basically x over your y, or other way around, sorry. Basically pages divided by days. So here, Paris, 98 pages over 15 days means 6.533 pages per day. Noel was at 6, Victor was at 11, and Gabby was at 21. So basically all of their pages were divided by the number of days it took them to read it, and that's how we got their rate. So Gabby had the highest rate. So Gabby was our winner. She read 21 pages per day. And our slowest would be Noel. Sorry, let me go back. And he read 6 pages per day. Okay, so it's just a matter of dividing that and then just looking and seeing who had the highest number, who had the lowest number. Simple as that. Next example, what is Andrea's rate of change between 0 and 8 minutes? Andrea is our dashed line. She at 0 minutes was at 0 miles, so she's at 0, 0. And over here at 8 minutes, she is at 50, not miles, meters. So those are the 2 points. We need to find the rate of change between those 2 times. So it's just a matter of setting it up. Y is on top, so remember, this is Y2, this is X2, this is Y1 and X1. So Y2 minus Y1 over X2 minus X1. That's how you find your slope, which is also rate of change. Should remember that, but there's a refresher in case you need it. So I did 50 minus 0 over 8 minus 0, which gave me 6.25 meters per minute. Now we need to find Sarah's rate of change for the first minute. Sarah is our blue line. She starts at 0, 0 as well, but at the first minute is at 20. So this point is at 1:20. So we set that up 20, because again, this is Y2, this is still Y1 and X2. So 20 minus 0 over 1 minus 0, which is 20 meters per minute. How long did Andrea stop to rest? So that would be where there was no change. There is no speed, no rate of change, which is right here. Rate of change is 0. So from there to there, so if we drop that down and look, that's 6 and 3. So remember, take your biggest minus your smallest. 6 minus 3 is 3 minutes. And then how far ahead is Sarah after 5 minutes? So at 5 minutes, Sarah is right here. Or I'm sorry, Andrea's right here, and Sarah's right here. So what is this distance in here? If we go over here, that's 60 and 30. So 60 minus 30 is 30 meters. Simple. All right, example 3. Determine the average rate of change for the function g of x equals 300,000 times 0.06 to the x power over the interval x is greater than or equal to 1 and less than or equal to 4. And then express the rate of change in words in relation to the domain. So this really is, sounds like it might be a little confusing, but really all you're doing is you're taking your formula and you're plugging in the 1 first to get a number. So 300,000 times 0.06 to the first power is 18,000. And then we do it again, but this time we use 4. So we do it twice, same exact thing, except we use 4 for the exponent, which gives us 3.88. And then this is your Y2 and your Y1. These numbers are your X2 and your X1. So we set it up as 18,000 minus 3.88. Because we led with 18,000, we have to lead with the matching X, 1 minus 4, which gives you negative 598, so negative 5,998.7. So that's your average rate of change over that period of time, average rate of change. Now, as far as expressing the change in words in relation to the domain, we would say the function g of x equals 300,000 times 0.06 to the x power is decreasing. So we don't actually put in the negative sign here. We say that it's decreasing. So if it was a positive, we would say increasing. Because it's negative, we say decreasing. And then we give the number without the sign. So decreasing at a rate of 5,998.7 over the interval x is greater than or equal to 1 and less than or equal to 4. So yeah, it's a little bit of writing, but you've got to make sure you include the formula, that you say increasing or decreasing, and what the number is, so that we know that you can make that connection between this says decreasing, that represents the negative sign, so I don't need to put that in there. And then include the domain so that we know that that rate of change is only for that particular domain. Because with an exponential function like this, that rate of change will be different depending on what your domain is. And then last but not least, error analysis. Problem said, find the rate of change over the function f of x equals 5 times 3 to the x power over the interval x is greater than or equal to 0 but less than or equal to 2. Paul said the average rate of change for the function is 6. Find and correct the average rate of change and explain where Paul went wrong. Okay, so basically just do the problem yourself. We know the answer is not 6 because it's error analysis. So just go ahead and, just like we did in the last problem, we're going to plug in 0, which is going to give us 5, because remember, anything to the 0 power is the same as 1, and 5 times 1 equals 5, which gives us a point. So when we used 0, that's our x, our y was 5. And then we do it again, but this time we use 2. So 5 times 3 squared. Well, 3 squared is 9, so 5 times 9 is 45. So now our points for this is 2, 45. To find the rate of change, I just did 5 minus 45 over 0 minus 2, which was negative 40 over negative 2, which simplified to 20. So which is the rate of change? So Paul's wrong because the rate of change is 20, not 6. All right, so that's it. A couple of slightly harder things this time around, but nothing too terrible. So, but as always, if you have any questions, please feel free to ask me, guys. Thank you. Have a good night.